Step 1. Percent composition. So, percent composition is the percent by mass of each individual element in a compound. It should always equal 100%, and if the percent composition is found, the empirical formula can be found next very easily. First, find the mass of the compound, then calculate the mass of each individual element found in the compound. Then, using the formula of mass of the element over mass of the compound times 100, find the percent composition of each element. Step 2. Empirical formula. Empirical formula is the simplest form of a compound. It is a whole number ratio, and it will show a divised ratio if the atoms of the elements in the compound are divisible by each other. Let's calculate empirical formula. So, first, determine the percent composition of each element. Then, find the number of moles in each element. Find the lowest value of moles out of all the elements. Divide each element's moles by the lowest mole value. Use the divided mole numbers as the subscripts for each element. And then, if any of the subscripts are decimals, multiply to get a whole number. Remember, when calculating an empirical formula, if two or more of the subscripts are decimals, you must multiply them by their common multiple. Every number must always be multiplied by the same number. Step number 3, molecular formula. Molecular formula is the actual formula of a compound. It will show all numbers even if two of them are the same. This formula is the true ratio of atoms in the compound. So, to calculate molecular formula, first you must find the empirical formula. Then you need to calculate the mass of the empirical formula. Using the molecular mass, divide the molecular mass by the empirical mass. You will get a number. That number will be used to multiply each subscript in the empirical formula. Remember, to find empirical mass, multiply the number of atoms of each element in the empirical formula by their atomic mass. This chart shows a compound, the empirical formula, and the molecular formula. As you can see, there are some differences, like CH2O. The molecular formula for that is C3H6O3. Let's do an example together. A sample of methanol contains 6.2 grams of carbon, 4.1 grams of hydrogen, and 15.9 grams of oxygen, with a molecular mass of 52.073 grams per mole. What is the percent composition of each element? First, we calculate the mass of the compound, which would be 6.2 plus 4.1 plus 15.9, which would give us 26.2 grams for the mass of the compound. Let's start with carbon. So, use the 6.2 grams and divide that by 26.2. Then multiply that by 100, which leaves us with 23.67% of carbon. Now, let's solve for the empirical formula. Using the percent composition of each element in the compound, you divide the percent composition by each element's atomic mass. Now, you are left with the number of moles in each of the elements. Using the lowest mole value, divide each of the moles for each element by the lowest value. That will give you your subscript numbers. Because we end up with the subscripts of 1, 8, and 2, and 8 is divisible by 2, the empirical formula ends up being CH4O instead of CH8O2. A tip when calculating empirical formula is to always circle or indicate the smallest mole value, like I have done with a star. Now, we're going to calculate the molecular formula of this compound. Using the empirical formula of CH4O, we're going to calculate the empirical mass, which is equal to 12.01 plus 4 times 1.01 plus 16.00, which will give you 32.05 grams. Now, the given molecular mass is 68.07 grams per mole. So, to solve for N, we're going to use 68.07 divided by 32.05, which gives us 2. Now, we multiply the empirical formula by that number 2 we were given, which makes the molecular formula CH8O2. Thanks for watching, and hopefully now you're a pro on the composition of compounds.